Welcome back. It's Calculus with Mr. Walton, the Unit 7 test review. That means all of Chapter 5. Please remember that we have already had a test on sections 5.1 to 5.3. However, now we're going to have a test that includes 5.1, 5.2, 5.3, 5.4, and 5.5. So you would want to make sure that you have the quizzes from all of those sections for part of your review. Today we're going to have a little bit of an extra practice test that I've worked out, and I will talk about it. And if you have any questions, please remember to come in and ask. First up, we have our calculator allowed section. We want to look at MRAM using 5 midpoint rectangles. Please remember that you are allowed to use your calculator with the Excel program on there. We're also going to use this for number 2. We're going to find numerical integration. That's your NINT function, or you're going to use the integral from 1 to 3.5 of the function f of x e to the x plus x cubed. If we look at number 3, what happens if we're going to use RRAM, but we're going to use volume? Please make note that we are going to change f1 of x into pi f of x squared. Do not, I repeat, do not change anything in your programs. Just make sure that you take this function and you put it right down here for f of x. If for some reason your calculator is not working, please make sure to come see me. Page 2. Graph the function over the given interval. So you're going to make sure that you graph it. You're going to give whatever key points would help. Zeros, maxes, mins. And again, we're allowed to use our calculator, so make sure that you use it. Okay, so once we have our function graphed, we can answer questions about the function, like in number 5 and 6. Please realize if we're doing regular definite integration, that's just the net area, versus number 6, when they say find the area, they're asking for the total area. So we would take the absolute value of that function in terms of what we put into the numerical integration for your calculator. All right? Then we're going to do definite integration using the calculator. That should be really straightforward. Okay, you're just going to plug this in and your calculator is going to give you an answer. Make sure you follow directions, round to the nearest thousandth. For number 8, don't forget the units. Make sure you read carefully. We're talking about Simpson's rule. We're talking about Simpson's rule in terms of 10 intervals, and we have 11 measurements. All right, so that means we have to calculate h, which turns out to be 24, and then we're going to plug it in and solve. In this one, even though you have the calculator, you're really doing this by hand. The calculator is just helping you with your numerical manipulation. Part 2, no calculator. You really want to try this without a calculator. Okay, what if I ask you to find an expression in terms of a and b so that I can evaluate appropriately? Okay, that means we're going to substitute in. I don't care which one of these two answers you have, as far as here, highlighted. However, one of them needs to be given. And if it's part of your multiple choice, please make sure that you're able to manipulate it one way or the other so that you choose the correct answer. Next, for number 10, we're evaluating, so make sure you practice evaluation without your calculator so that you don't lose track of signs, that you work it out, and you take your time. Same thing for number 11. However, in this case, we need to keep track of our unit circles so that we know that the tangent of pi over 4 is 1 and the tangent of pi over 6 is the radical 3 over 3. And then what can I do to make those similar / the same? If nothing, then I leave it as it is. All right, because that exact answer is more appropriate than working it out, keeping decimals, and having an inexact answer. For number 12, right? We're looking at things we know to be true versus things we don't know. We're evaluating truth versus falseness on our Roman numeral 1, Roman numeral 2, and Roman numeral 3. If we look at Roman numeral 1, not a property, so we don't know it's true. For 2 and 3, they follow the properties for integrals, therefore we know them to be true. Therefore, which solution, that would be C in this case, answers this question? And that's what we pick. Next up, use the trapezoidal rule, and we want to do it by hand. Make sure you find H, make sure you make an X and Y chart, make sure you plug in appropriately, keep track of your signs, and double check your work. Alright, so that's a good one to keep track of. Our next problem, number 14, really like this one because it asks you to manipulate the integral and to solve for a missing k value that makes this true. So we practiced this in class, we practiced this in homework, we've gone over it, and now there's another example for you to follow. Make sure you use your properties of integrals. Okay, for 15, if I'm finding the integral from -1 to x of f of t dt, I may not know what that is. But if I'm taking the derivative of that, remember that that's the derivative of capital F of x, which means it's just f of x. And given here, f of x is 3x plus 2, so that's our fundamental theorem of calculus. Now we're going to look at particle motion a little bit. Make sure that we understand what's occurring given what's being asked. So this is the second time you've seen this, so make sure we pay attention to the keys for going between whether it's a derivative, is it the integral, what is occurring. So the big key for this is identifying that s of t being the integral means that I have s of t as my capital F of x, meaning the derivative is little f of x, meaning that this is the velocity graph. That's the key. This is my velocity graph. Once I know that this is the velocity, now I know about acceleration, I know about position, and I can appropriately answer my questions. This is going to be a PDF for you to look at. You can try to solve it. You can work it out. You can go over it. If you have any questions, you come in and see me. Good luck.